In the video for exercise 1612 and 1613, we discussed how you can use curved arrows to show how nucleophiles attack electrophiles, how opposite charges attract to make reactions happen, and we discussed and introduced the first four curved arrow patterns. So here, those four were 1, nucleophilic attack, 2, proton transfer, 3, loss of a leaving group, and 4, rearrangement. So we're just going to do some more practice in this one, 614, in recognizing curved arrow patterns. In this case, it's going to be for multi-step reactions. So you'll really get a sense of how you can take what looks like really complicated stuff and boil it down to some simple patterns. So let's try to recognize these. This first step, we have a nucleophile attacking an electrophile. The electrophile is a hydrogen, so this is proton transfer. In the second step, we have a nucleophile attacking an electrophile. The electrophile is not hydrogen, so that is nucleophilic attack. In the third step, we have a nucleophile attacking an electrophile. The electrophile is hydrogen, so that is a proton transfer. And so, how would you describe this to somebody? It would be really hard if you didn't have these terms, but with these terms you could say, this reaction is a proton transfer, followed by a nucleophilic attack, followed by a proton transfer. You could see how those patterns help you to simplify and organize conceptually what's happening. In this next one, we have a nucleophile, pi bond, attacking an electrophile. That sulfur is slightly positive because it's bonded to so many electronegative oxygens. Nucleophile attacking an electrophile. The electrophile is not hydrogen. That's nucleophilic attack. In the second step, a nucleophile, the lone pair and the slightly negative oxygen, attacks an electrophile. The electrophile is hydrogen, so that's a proton transfer. In the third step, we have a nucleophile attacking an electrophile. The electrophile is a hydrogen, so that's another proton transfer. So this whole big complicated looking thing is just a nucleophilic attack followed by 2 proton transfers. In C, we have a nucleophile, we have a negative charge with lone pairs attacking an electrophile. The electrophile is hydrogen, so that is a proton transfer. In the second step, we have a nucleophile attacking an electrophile. The electrophile is not hydrogen, so that is nucleophilic attack. In the third step, we have this molecule coming off of the carbon chain. It's getting kicked off by the oxygen, but the point is that it's coming off of the carbon chain. It's not here anymore. So if something gets kicked off of a molecule, takes its electrons with it and just leaves, that's loss of a leaving group. So that whole reaction is a proton transfer followed by a nucleophilic attack and loss of a leaving group. For D, we have a nucleophile, lone pair, negative charge, attacking an electrophile. The electrophile is a hydrogen, and so that is a proton transfer. In the next step, we have this chlorine just popping off of the molecule. You can see it disappearing there. And notice the notation, minus chlorine. That means we're not interested in the chlorine, it's leaving our field of view. It's still knocking around the beaker, but it's not going to participate in any reactions that we're interested in. Now it's true this is getting kicked off by that lone pair, but the point is it's getting kicked off the molecule, and so that is loss of a leaving group. In the third step, you have a nucleophile, it's attacking an electrophile, and so that is nucleophilic attack. Finally, you have another nucleophile attacking an electrophile, but the electrophile is a hydrogen, so that is proton transfer. So if this were a reaction that you had to remember, you wouldn't want to start memorizing the curved arrows right away. You would want to learn the curved arrow patterns, first proton transfer, second loss of a leaving group, third nucleophilic attack, fourth proton transfer. And once you have those down, you'll see that the curved arrow patterns are much easier to remember. For E, the last one for this, for E, we have a nucleophile, negative charge, lone pairs, attacking an electrophile, but the electrophile is a hydrogen, and so it's really a proton transfer. In this next one, you have a nucleophile, the pi bond there, attacking an electrophile. Notice the carbon in carbon dioxide is really slightly positive, so that's definitely an electrophile. Nucleophile attacking an electrophile, that's nucleophilic attack. Notice the electrophile is not a hydrogen, so it's not proton transfer. In this next one, you have this full negative charge with lone pairs. It looks like a nucleophile attacking a hydrogen. The electrons stay on the molecule, but the effect is the hydrogen goes from one molecule to another. That's a proton transfer. And so you can classify all of these reactions. You can clarify what's happening in them conceptually just by recognizing these curved arrow patterns.